So first of all, I would like to understand, like, last year, January 2021, you released the first batch of samples of your first generation batteries. So over the course of the one year, like, what has been the key learnings, like, that through the samples that you had shared or provided to the market?
So the key challenge is actually to reach sufficient cycle life for these batteries. So these are full charge and discharge cycles. And actually we had just this morning a press release that shows that we've achieved 1200 of consecutive fast charging cycles. So this has been our goal, is to reach this critical milestone of consecutive extreme fast charging cycles. So if you look on the press release from this morning, you'll see that we actually released a chart that shows the consistent performance. And the 1200 cycles, once you pass the 1000, this is already sufficient for the warranty of the vehicle. Because let's say its charging is like 300 miles. So if you have 1000, it's a warranty for 300,000 miles of the vehicle. No, so again, we are talking about 1,000 cycles. Each one is 460 or 80 kilometers. So it's 480,000 kilometers, 500,000 of kilometers.
Okay. So you're talking about one cycle is almost 480 kilometers.
Yes, I mean, it really depends on the design of the pack of the vehicle. This was originally designed for, let's say, a Tesla-like model, not necessarily a scooter. Right. But the chemistry can work also on two-wheeler, three-wheeler, it doesn't matter. The goal or the challenge here was to optimize a chemistry that would always be able, on a daily basis, would be able to apply an extreme fast charge power. So if you come to a sufficient charging station, let's say in a vehicle, we are talking about 350 kilowatt station, which is a very powerful station, but a normal battery cannot take all this power. Correct. Because of resistance and heat and metallization and safety issues. So what we have developed is actually a battery that is safe, that can sustain 1,000 plus of these fast charging cycles all the time. Right. So each cycle is a fast charging cycle. So, and this is the breakthrough, because in normal batteries that are based on graphite, you cannot, even if you do one or two of these times and the battery is dead, we are talking about 1,000 times that you can charge them in 10 minutes, let's say.
So basically, like, what I gather and understand right now, like that, if a end consumer does not require fast charging and he, like, utilizes as an emergency or on the go, the life cycle of the battery will substantially increase from 1,200 to, say, it could be almost double.
Correct. Exactly. Right. We are talking about the extreme scenario where you don't have a slow charging option. You always, let's say you stop on the highway, you have 5 or 10 minutes, you want to get fully charged and be on your way. Okay. So we are optimizing for this scenario that it was considered impossible to do. And this is why, it's such a big news that StoreDot chemistry of the battery is such that allows for consecutive extreme fast charge cycles.
Okay. And Doron, I remember last year you had told me, like, that as you correctly mentioned, that, like, you were looking at the 4-wheeler segment, 2 and 3-wheeler segment was not something that you were, like, being aggressive on. So right now, like, how did you like, come to the conclusion, your first partnership, Indian partner, the 2-wheeler segment? So how did the whole conversation happen?
So I think it's an alignment on the vision. India in some aspects is a bit behind in terms of 4-wheel implementation. So if we want to reach the market share, the significant market share in four-wheelers, we need to start as early as possible with partners that share the same vision as StoreDot, like Ola. And myself and Bavish, the CEO, had many discussions about the need for zero emission world and sustainability. And currently we are starting with the two-wheelers because this is what India currently requires.
Okay.
But Ola is already designing four wheels.
Correct.
And in the next few years, they will also be on the road. So we will align with the roadmap and the timeline going from the two-wheeler to the four-wheeler that is aligned with the vision of Ola.
Correct. So basically, StoreDot would power both the two-wheeler and the four-wheeler, right? For Ola.
Exactly, because you need to understand that what is important is the optimization of the chemistry. And fast charging is important both for two-wheelers and four-wheelers. So we have optimized initially the chemistry for four-wheelers, but now we need to do the right form factor, which might be a cylindrical cell that we've been also working on, or might be smaller pouches that we also have as samples already. So it's a matter now of the application and the implementation of the chemistry into the two-wheelers. For us, it's a stepping stone to reach the holy grail of a full vehicle that charges in minutes.
Okay. And what about the battery chemistry? Is there a different battery chemistry for the Indian market or for the two-wheeler segment? Can you let us know what's the battery chemistry that you've?
So no, the chemistry is a silicon-based anode. That is, the claim to fame of StoreDot in this current generation. We are using the same chemistry, but as I mentioned, the form factor, meaning the packaging,
correct,
for the scooter will be in a different.
Could be cylindrical.
Yeah, maybe. Yeah, but maybe the 21700 and not the 4680 that we've also been demonstrating.
Okay. And you also mentioned, given the ongoing supply chain issues globally, does it also have impact on your potential manufacturing operations, given the current situation, say in the Russia-Ukraine conflict, lockdowns in China, the lithium composites being mainly controlled by the Chinese players, 80% of the world reserves?
Correct. So yes, of course there is impact. We are being impacted similarly to all the battery makers. I think the number one concern is around the supply of the cathode materials like the nickel, the manganese, the cobalt that we also currently use in the cathode. So there is a temporary price hike for these metals. But I think, as we progress in 2022, this will be a temporary hike, and we will see over time, the compensation of this cost, because, if you look year on year on what is happening to the price of batteries, there is like a 5 or 7% decline. If you look at, let's say, on a 10 to 15 year horizon. So yes, this year is going to be stressed, but we are not in mass production yet. So for us, again, assuming that this war is going to be over in the foreseeable future, so next year, as we go to mass production, we will basically go back to the normal cost reduction curve that we have been planning on.
Okay. And since you mentioned about the global supply chain, the for price factor and everything, do you also foresee that you will look at different battery chemistries also, and what developments are taking in that particular context?
Yes. So the number one alternative is to use what is called LFP batteries, and we've already started investigating the implications of using LFP as opposed to NMC in the cathode. The first, I'd say the most concerning impact is that you lose about 20 to 30% of the energy, of the range of the vehicle. So we are looking for innovative ways to compensate on this loss, either through some what is called cell-to-pack design, meaning building larger cells and less modules, less overhead in the vehicle. So there'll be more efficiency by implementing the LFP technology. And also we are trying to optimize the silicon anode that has higher energy. So it would also compensate some of the LFP limitations. So yes, you know, especially if you look at what is happening in China, and also Tesla took the decision on more focus on LFP. But again, I think all this trend is a temporary trend because of the supply chain stress. But as we move to 2024, 2025, I think NMC will still be the winning solution just because it provides so much better energy.
Right. And like, you know, since you mentioned that, like, you know, you've tied up with Ola and like, you know, in line with you have a common vision of, like, you know, adopting or accelerating AV adoption. How much stake has Ola taken, or how much investment has Ola made in StoreDot? And secondly, will the Ola also, like, you know, be investing further more in the company in the coming days?
So, you know, this is part of our round D that in total was around 70 million. We don't give the internal breakdown, but it also doesn't matter because what is important is that we have signed a strategic collaboration agreement. And, you know, regardless of the equity, because StoreDot, you know, is already, you know, an expensive, or I would say high valued company. So, you know, it's difficult to take a large stake at StoreDot. But what is important for us and what is important for Ola is to take the market share of fast charging batteries in India through this collaboration. And this investment and strategic collaboration are actually designed to enable taking this significant market share in the coming years.
Correct. So, so this investment, as you mentioned, is part of the 80 million Series D funding round, which also saw company like VinFast also entering the investing, right?
This is the same round, yes.
Okay. No, I was just wondering, like, you know, if like, you know, Ola was the only one investing in Series D, or there were others also, because there was no clarification.
No, the number of, I would say, in total, we haven't even announced all the participants in this round, but Ola is one of 5 that are in this round.
So from India, Ola is one of them, or there are other from Indian market?
No. India, Ola is the only one from India.
Yeah. Okay, and VinFast is the other one.
VinFast is the other one that we have announced. Also, Eve Energy in China.
Correct.
Also, BP from the UK.
Correct.
And we will announce a couple more in the coming weeks. Yeah.
Okay. And in total, how much funding will you be raising in Series D?
So Series D is done. The total is like you said, is 80 million. But we don't need any additional funds for this round.
Okay. So till date, how much you have raised?
200.
Okay. And like, you know, you mentioned that SXC, your technology, the extreme fast charging technology, 1200 cycles. What about the cooling part? Because right now, Ola's S1 and S1 Pro scooters that have been launched in India do not have a liquid cooling, and, like, you know, India has a very like, you know, temperature variations, right, from the north to the south to the east to the west. Secondly, the kind of congestions you see, I'm pretty sure the scenario in India is completely different that of the other parts of the world. So over here, how will you ensure that the battery temperatures remain at an optimal level? Because we have seen some of the scooters in India, engulfing in flame during charging or during normal course of riding.
Yes, so this is definitely an engineering challenge. It's less, I would say, of a chemistry challenge because our chemistry can sustain, 50 degrees ambient temperature. We need to make sure that during charging, there is also some air cooling that would make sure that the battery does not go above, let's say, 45 or 50 degrees. So we have demonstrated even back in 2019, we've demonstrated 5-minute charging of a scooter with some air cooling with fans. And then we've repeated that later that year in London, also in a live event. So we showed that this is possible to do, but of course there would need to be some work on the design of the scooter. So there'll be sufficient cooling, not only during charging, but also during the operation of the vehicle. But I would say this is a challenge for any type of battery that you would introduce. So it's not, specific to XFC technology. Okay. But this is definitely something that we would need to work on together with Ola. As it has to be solved as a system solution and not necessarily a battery solution.
Correct. And if I'm not wrong, you have a patented technology that ensures that the optimal dissipation of heat is emitted during the ultra fast charge. Can you just give, explain it to me in, if in simple terms, given the fact I'm from a non-technical background, so it will be simpler for me to interpret the same.
So if you're talking about the self-healing technology or this one? We have over 100 patents, so I need to know specifically which one you are looking
at. The heat dissipation.
Yeah.
You mentioned
the heat dissipation. The one that we patented specifically on heat dissipation is focused on the cylindrical cell and the ability to dissipate the heat also from the center of the cylinder and not only from the outer perimeter. So it's basically a design of the cylindrical cell that is optimized for heat dissipation.
Okay.
So you can think about it. For example, you have like a hole in the center. It's a void that you can actually place the cylinder on, let's say, on a cooling rod. Mm-hmm. The rod is the vehicle to extract the heat, and it comes directly out of the center of the cylinder, okay. As opposed to try to cool everything with from the outside.
Okay. Okay. So the void basically, you can squeeze out the air, through basically air cool or liquid cooling, whatever way you want to plan it. But basically through the void, the heat gets dissipated out of the batteries.
Correct.
Okay. Okay. And is it possible that the Ola's current scooters, the S1 and S Pro, could use your batteries without much of engineering change, or will it require a complete overhaul for the products?
So since we are not yet in mass production, we are more focused on future generations. Okay. Starting next year. So by definition, this will be some different design.
Okay.
That would be optimized for the cooling.
Okay. And your first product, the first battery from StoreDot in India in a commercial product will be, you're targeting by when? What is the timeline like?
So I would say, depending on where it will be produced and the timeline of ramping up of Ola's facilities, we are currently producing in China.
Correct.
So in China, potentially we can produce 2023, but in Ola's facilities, it will probably be 2024.
Thanks a lot, Doron. Have a great day ahead and good talking to you again.
Thank you.
Take care. Bye.